In this module, we will discuss and explain deeply the big data architecture layers that we already explained briefly in the last modules. First, we will start uh, with discussing and explaining the data source layer of big data architecture, which is responsible for collecting the data from various sources. There are many different types of data sources that can contribute to big data. These sources can be categorized into three main types of data: structured, semi-structured, and unstructured. Structured data is highly organized and is usually stored in additional database format. Like a relational database, it can be easily analyzed using database management systems and is often generated from transactional systems. Semi-structured data has more structure but also includes unstructured elements. For example, XML, JSON data formats have some structure but also allow for flexible and dynamic data elements. Semi-structured data can be analyzed using specialized tools and techniques like NoSQL databases and Hadoop. Unstructured data. This type of data has no predefined structure and is typically generated in large volumes. Example of structured and unstructured data includes text documents, images, videos, and social media posts. It requires specialized tools and techniques to analyze, such as natural language processing and machine learning. Let's take a closer look to some example of big data sources. Social media or networks data, such as Instagram, Facebook, and Twitter, generates massive amounts of data every day or even every minute, including posts, comments, like, shares, and users' interactions. This data is largely unstructured and can be difficult to analyze without the proper tools and techniques. Mobile mobile device data. Mobile devices generate a large amount of structured and semi-structured data, including location data, app usage, and search history. This data can be used to provide insights into user behavior and preferences. IoT sensor data. IoT devices such as sensors, smart thermostats, and fitness trackers generate vast amounts of structured and semi-structured data. For example, a sensor in a factory can generate data on temperature, pressure, and machine performance. Transactional data, such as financial transaction, online purchases, and customer interactions, can provide valuable insights into customer behavior and business operations. This data is usually structured and can be analyzed using traditional relational databases. We will be discussing the big data ingestion layer, which is responsible for receiving and processing large volumes of data from various sources. The big data ingestion layer is a crucial component of any big data architecture, as it ensures that data is transformed and prepared for storage and processing. By cleaning and transforming the data, organizations can ensure that the data is accurate and consistent, which can lead to more accurate and meaningful insights. There are several tools and technologies that can be used for big data ingestion, including Apache Kafka, Apache Flink, and Amazon Web Service Kubernetes. These tools provide a range of features and functionalities like real-time data streaming, data transformation, and data quality checks. Apache Kafka is a distributed streaming platform that can handle high volume of data in real time. It's often used for real-time data processing and streaming and data integration. Apache Flume is a distributed, reliable, and available system for efficiently collecting, aggregating, and moving large amounts of log data. It is often used for data ingestion from various sources, like social media platforms, web servers, and mobile devices. Amazon Kinesis is a fully managed streaming data services that can handle large volumes of data in real time. Big data ingestion is a crucial component of big data architecture. One example of data ingestion is collecting data from multiple social media platforms like Twitter, Facebook, YouTube, and Instagram. To do this, we can use a tool like Apache Kafka, which can collect data from each platform API and transform it into a format that can be easily stored and analyzed. Once the data is ingested, it can be sent to a storage layer or real-time processing layer for further analysis. For instance, we can analyze customer behavior, track brand mentions and the sentiment, and monitor social media campaigns. Using data ingestion to collect data from multiple sources enable us to gain valuable insights that can help improve business operation and drive growth.